Hello students, in my last lecture I had explained to you different types of velocity time graph for uniformly accelerated motion and non-uniformly accelerated motion. Today we shall solve in-text questions of NCERT page 107. But before this there is an activity. So first of all, we see what is given in activity 8.10 activity. And I had assured you that I shall explain each and every activities of NCERT text because it is very useful for our knowledge. So see activity 8.10. What is given here? See in NCERT, Firoz and his sister Sania go to school on their bicycles. Both of them start at the same time from their home but take different times to reach the school. Although they follow the same route, table 8.5 shows the distance traveled by them in different times. See, now in table 8.5, distance covered by Firoz and Sania at different times on their bicycles. This is time. They start their journey at 8 a.m. early in the morning. Now this is the data for distance traveled by Firoz in kilometer and this is by Sania in kilometer. So at 8 a.m. both of these start their journey from their respective houses. So distance traveled at 8 a.m. is 0. Now at 5 a.m. that is after 5 minutes. Firoz has travelled 1 kilometer distance, but Sania has travelled only 0.8 kilometer distance. Again see, at 8:10, that is after next 5 minutes, the distance travelled from the house of Firoz is 1.9 and from the house of Sania it is 1.6 kilometer. Similarly, after every 5 minutes, the distance travelled is given here. So, what is the question here and how we shall face it? The question is plot the distance time graph for their motions on the same scale and interpret it. So, we have read different graphs. We have read distance time graph, velocity time graph, uniformly accelerated motion, non-uniformly accelerated motion, but now we shall really solve questions related to it. So how we can represent it on graph? So see, first of all, to represent it on graph, so suppose this is x-axis and this is y-axis. Really learn how we can solve problems related to graphical situations. So this is x-axis and this is y-axis. Suppose this is origin. Now here time is given in minutes. So we shall take time, but different times is given according to our watch. So take time along x-axis, time t in hours. 8, 8, 5, 8, 10. Suppose the journey starts from 8 a.m. So on this origin, that is 0, 0, we take 8 a.m. Now after every 5 minutes, this is 8, 5, this is 8, 10, this is 8, 15, equidistant scale. We take equidistant scales, 8, 20 and 8.25. Now see what is the range of distance travelled. Range of distance travel is up to 3.6 kilometer. So if we take distance in kilometer, along y-axis, and the scale of distance we take equidistant point of 1 kilometer each. So this is 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, so on. Now, we shall draw both graph for both Sania and Firoz on the same scale. So first of all, we draw graph for the movement of Firoz. So see here, table 8.5. In table 8.5, what we see? At 8 a.m., the distance traveled by Firoz is 0 kilometer. So at 8 a.m., this is the point hour. Once again, see, at 5 a.m., that is after 5 minutes, the distance traveled is 1 kilometer. So at 5 a.m., this is the point here, 1 kilometer. Again, see, at 8:10, that is after next 5 minutes, the distance traveled is 1.9. So see, this is the time, and probably this will be the point. You can use graph papers to draw these graphs more scientifically. Just here we are giving the representation, symbolic representation of graphs, because it is not actual graph paper. On actual graph paper, you may trace it more scientifically. Now see, at 8:15, the distance traveled is 2.8 kilometer. So at 8:15, this is 3, so just below 3, it may be 2.8 kilometer. And at 8:20, Firoz has traced his journey, that is, he reaches to destination. So at 8:20, the distance traveled by Firoz is 3.6. Suppose this is just below 4, so 3.6. Now, if we join these points, then we find distance time graph for Firoz. So this is distance time graph for Firoz, right here. Distance time graph, distance time graph for Firoz. Now, on the same scale, we have to trace distance time graph for Sania. So once again, now we shall follow the data given for Sania. See, at 8 a.m., the distance traveled by Sania is 0 kilometer. So once again, this is the same point for Sania also. Now see, at 8:05 a.m., the distance traveled by Sania is 0.8 kilometer. So see, just below 1 kilometer, that is nearly this. Now, next data is at 8:10, the distance traveled by Sania is 1.6 kilometer. So see, at 8:10, this was 1.9, and here it is 1.6. So suppose 1.5 below it, nearly. At 8:15, the distance traveled by Sania is 2.3. So 2.3, and for it, Firoz, it was 2.8, so below it. And at 8:20, the distance traveled is 3. So at 8:20, the distance traveled by Sania is only 3 kilometer. This is 3 kilometer point. And at 8:25, she finishes her journey. So at 8:25, she finishes his journey. Now, if we meet all these points, then what we find? We find, see, this is the nature of the graph. We meet all these points freehand. So this is distance time graph for Sania. Distance time graph for Sania. So dear students, now I hope that you can trace distance time graph for different situations, and you can solve different problems related to it. So I have given focus for your learning. Now, see, there are some in-text questions. I am giving the answer of these questions. If you have solved yourself, then please tally the answers and try to improve the level of your answer. I have also suggested you many times that this is your regular study, and you start solving in-text questions, exercise, making notes in perfect way. So see, what is question number 1? See here, question number 1, page 107 of NCERT. Question number 1 states that, see, what is the question here? What is the nature of the distance time graph for uniform and non-uniform motion of an object? We have traced, see here, we have traced distance time graph. So see, really, this is distance time graph for uniform motion. What is the nature of distance time graph for uniform motion? It is a straight line with some slope. So answer will be, it is a straight line with some slope. And see really the answer yourself. What is the answer? And second question is that non-uniform motion distance time graph. See here, this is distance time graph for non-uniform motion. Is it a straight line? No, it is curved. So with the concept of these things, we can write answer. And what is the nature of the distance time graph for uniform motion? To answer, our first question will be the nature of distance time graph is a straight line with some slope, but the nature of distance time graph for uniform motion, add here, the nature of distance time graph for uniform motion, but the nature of distance time graph for non-uniform motion is curved. It is not a straight line. Now see, what is second question? Second question is that, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? So we had plotted distance time graph in last lecture. See the answer of this question once again. Suppose this is x-axis, this is origin, this is y-axis, this is time. Suppose time is given in hour and it is distance given in kilometer. So what is the question here? The question is here, see, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? Suppose the scale of time here is 1 hour, 2 hours, 3 hours, and on y-axis the scale is given 5 kilometer, 10 kilometer, 15 kilometer, etc. Now, if initially the distance traveled is 10 kilometer from reference point, again after 1 hour the distance is same, after 2 hours the distance is same, after 3 hours the distance is same. If we join all these points, then what we find? We find distance time graph which is parallel to time axis. It indicates that the object does not change its position with respect to its immediate surrounding with respect to time. So this is the definition of rest. So this situation shows that this situation shows that the object does not change position, does not change its position with respect to its surroundings in time. That is, the object is at rest. So this situation, if the distance time graph is parallel to time axis, then it gives us the object is at rest. Now, two questions are more. See, what will be the answer of these questions? Question number 3. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? See one situation. So, to solve such types of questions, we must draw graphs for our scientific knowledge. This is x-axis, this is y-axis, this is origin. Suppose we have taken along x-axis time in second. Not always our. We may time in seconds, we may take time in minutes, we may take time in hours according to our situation. And along y-axis, suppose this is a speed time graph. See here, what can you say about the motion of object if it's a speed time graph? So along y-axis we have taken a speed in meter per second. Here time is taken in second and a speed in meter per second. Suppose our scale is 5 seconds, 10 seconds, 15 seconds, 20 seconds, so on. And the speed of any object is 10 meter per second, 20 meter per second, 30 meter per second, so on. Now, suppose if time is 0 and the speed of any object is 20 meter per second. After 5 seconds again, the speed is 20 meter per second. After 10 seconds, the speed is 20 meter per second. After 15 seconds, the speed is same, and so on. So if we join all these points, then what we find? We find a speed time graph. This is a speed time graph and this is parallel to the time axis. So what is the observation here? Here our observation is that the speed of object is same, that is constant. It does not change with respect to its surrounding in time. So if a speed time graph is parallel to time axis, then it indicates that the speed of the object is constant speed, constant. That is, it is non-accelerated motion. That is, it is non-accelerated motion. Here acceleration is 0. That is, it is non-accelerated motion. Here acceleration is 0. Rate of change of velocity is 0 because here velocity does not change. Now next, question number 4. What is question 4 here? See here. What is the quantity which is measured by the area occupied below the velocity time graph? In our last two lectures, I have explained it clearly and the articles are given here. See, in page 105, article 8.4.2, in this article also we had seen that the geometrical area between velocity time graph and time axis gives us what? Displacement or distance here. Similarly, see here, in this graph also we had explained that the area between velocity time graph and time axis gives us distance. So here the answer will be the area between velocity time graph and time axis gives us distance or displacement if the object travels on a straight path. A straight path with uniform motion. With uniformly accelerated motion or uniform motion. Or uniform motion, both situations. Now, before concluding this lecture, I give you some homework. So today's homework is once again solve yourself in text questions of page 107 and CRT yourself. Thank you very much.